Next we are going to discuss about mole concept. Now before we come to mole concept, let's see some terms. The first term is atomic mass. We know that mass of an atom is very small. So now there are sophisticated techniques to find the atomic mass or mass of an atom. But in earlier time, hydrogen atom being lighter was taken as the standard and it was given a mass equal to 1 without any unit. And the mass of other elements were given relative to this mass. But now scientists took carbon-12 as standard to find the atomic masses of elements. Now, carbon-12 is the isotope of carbon atom. Isotope means atoms with same atomic number but different mass number. And carbon-12, the isotope is represented like this. C, and we have 12 on left hand side as superscript. So this is carbon-12 isotope. It has same atomic number but different mass number, and 12 is the mass number of carbon. So carbon-12 isotope is now taken as standard, and carbon-12 isotope is given mass exactly equal to 12 AMU, and AMU is called atomic mass unit. So scientists took carbon-12 isotope as standard and they gave the mass of carbon-12 isotope as 12 AMU, and masses of other elements were found relative to this standard. Now we can define 1 AMU as the mass equal to 1/12 the mass of one carbon-12 atom. 1 AMU is defined as the mass equal to 1/12 the mass of one carbon-12 atom, and 1 AMU, when you calculate, we get the value as 1.66 into 10 raised to minus 24 gram. But now we know the atomic mass of all the elements are found out experimentally. Now this atomic mass unit in present time is replaced by another unit called unified mass. Denoted by small u. So now the term atomic mass unit or AMU is not in use. We have unified mass U. For example, we know that the atomic mass of hydrogen is 1. So we can say atomic mass of hydrogen is equal to 1 U. Then atomic mass of oxygen is 16 U. This is the atomic mass of oxygen, 16 U. So now we have unified mass instead of atomic mass unit. Now next, let's see what do you mean by average atomic mass. Average atomic mass. Average atomic mass. Now this average atomic mass is used in case of elements which can exist as isotopes. So if we have different isotopes of an element given, you can find the average atomic mass of that element. For example, I have written a problem question on the board. Calculate the atomic mass average of chlorine using the following data. And you can see in the question the two isotopes of chlorine is given. One is chlorine 35 and the other is chlorine with mass number 37. And the natural abundance, percentage of natural abundance of chlorine isotopes are given. Chlorine 35, 75.75, the other is 24.23. And the molar mass is also given. Now how will you find from this given data the atomic mass or the average atomic mass of chlorine? So we are going to do the average atomic mass of chlorine. average atomic mass of chlorine is equal to, we know that the percentage of abundance of chlorine 35 is 75.77%. So I am going to change that percentage. So it becomes 0.7577 into molar mass is 34.9689 plus the percentage of abundance of chlorine 37 is 24.23%. I'm going to change that percentage. So I get 0.2423 into 36.9659 and you get the answer as 35.5 U. So this is the average atomic mass of chlorine, 35.5 U. Now this is average atomic mass. Now let us see next term is molecular mass, number 3. Molecular mass. You know how to calculate molecular mass. Molecular mass is the sum of atomic masses of all the elements present in a molecule. For example, suppose you are asked to calculate the molecular mass of water. Molecular mass of water is equal to sum of atomic masses of all the elements. We know the atomic mass of hydrogen is 1, but we have 2 hydrogen atoms, so 1 into 2, plus atomic mass of oxygen is 16. So 16 plus 2 will be equal to 18 U. That is, U is the unified mass. So the unit of molecular mass is U. Now suppose you are asked to find the molecular mass of methane. Molecular mass of methane. We know the formula of methane is CH4. Now methane, carbon, atomic mass of carbon is 12 plus hydrogen 1. We have 4 atoms of hydrogen, so into 4, which is equal to 16 U. So this is molecular mass. Now next term is formula mass. Formula mass. Now the calculation of formula mass is same as molecular mass, but you use the term formula mass for ionic compounds like sodium chloride. So formula mass calculation same like molecular mass. So formula mass is the sum of atomic masses of all the elements present in formula unit of a compound. And example, suppose you are asked to find the formula mass of sodium chloride. We know sodium chloride, sodium, formula mass, atomic mass of sodium is equal to 23, chlorine is 35.5, and you get the answer as 58.5. The unit is also same, which is equal to U. So 58.5 U. This is the formula mass of sodium chloride. Okay. Now the next term that we are going to see is mole concept. Mole concept. Now again, what do you mean by the term mole? Mole means the amount of substance, that is, mole is a quantity that is used to count the number of atoms, molecules or ions. And this mole concept again is based on a standard, and scientists again they took carbon-12 isotope to study the mole concept, and they took 12 gram of carbon-12 isotope. So 12 gram of carbon-12 was taken as a standard to study the mole concept. Now scientists found that 12 gram of carbon-12 isotope contain 6.022 into 10 raised to 23 atoms of carbon. So So 12 gram of carbon 12 isotope contain 6.022 into 10 raised to 23 atoms of carbon. And they gave this number, or they called this number as 1 mole. So we can write 1 mole is equal to 6.022 into 10 raised to 23 particles. Or how can you define 1 mole? 1 mole is defined as a group of 6.022 into 10 raised to 23 particles of a substance is called 1 mole, and 1 mole is equal to 6.022 into 10 raised to 23. Now this number 6.022, and we know that the unit of mole, MOLE, is MOL. This is the unit of mole, MOL, SI unit. Now, this number 6.022 into 10 raised to 23 is also called Avogadro number or Avogadro constant. So, Avogadro number or Avogadro constant. And Avogadro number or Avogadro constant is denoted by capital N subscript capital A. So the value of Avogadro number Na is equal to 6.022 into 10 raised to 23 particles per mole. This is the value of Avogadro number. So how can you define Avogadro number? Avogadro number, and you know that these are the particles present in 12 gram of carbon 12. So Avogadro number is the number of atoms. In 12 gram of carbon 12 isotope, we have atoms. So Avogadro number is the number of atoms present in 12 gram of carbon 12. Now, we'll see an example. So you can say that 1 mole is equal to 6.022 into 10 raised to 23, which means that 1 mole of any substance, let it be an atom, molecule or ion, it contains Avogadro number of particles, or 6.022 into 10 raised to 23 particles. Okay, that is, write that sentence, 1 mole of any substance. When I say substance, it is atom, molecule or ion, contain 6.022 into 10 raised to 23 particles. When I say particles, again, if the substance here is atom, we have atoms. If it is molecule, then we have Avogadro number of molecules, like that. Now, I'll give an example. Example. 1 mole of oxygen atom will contain how many atoms of oxygen? Will contain 6.022 into 10 raised to 23 oxygen atoms. Now, 1 mole of O2, here O2 means it is molecule, oxygen molecule, will contain how many molecules of oxygen? Again, Avogadro number of oxygen molecule. Now, 2 moles of oxygen molecule will contain Avogadro number into 2, because it is 2 mole. 1 mole contain Avogadro number, so 2 moles will contain 2 into Avogadro number of O2 molecules. Now, another example. 1 mole of chloride ion, Cl minus ion, will contain Avogadro number Na, that is 6.022 into 10 raised to 23 Cl minus ions. So, in general, we can say 1 mole of any substance will contain 6.022 into 10 raised to 23 particles. Okay, so this is mole concept. Now next let us see what do you mean by gram atomic mass. Gram atomic mass or GAM. G-A-M. Now, gram atomic mass is the atomic mass expressed in grams, or we can also define it as mass of 1 mole of atom. So, gram atomic mass is the mass of 1 mole of atom, and this mass of 1 mole will be expressed in grams. Okay. Now, example, 16U represents which atom? One oxygen atom, whereas 16 gram represents 1 mole of oxygen atom. This is the difference. So here 16U means it is the atomic mass of oxygen. So it represents 1 oxygen atom. Now when I say 16 gram, this is the atomic mass of oxygen represented in grams, or it is the mass of 1 mole of oxygen atom, 16 gram. So 16 gram represents 1 mole of oxygen atom, and we know that 1 mole of oxygen atom will contain Avogadro number of particles. So this is equal to 6.022 into 10 raised to 23 oxygen atoms. Or we can say 6.022 into 10 raised to 23 oxygen atom will weigh 16 gram. Okay, now another example. One U represents 1 U shows the atomic mass, and 1 is the atomic mass of hydrogen atom. So 1 U represents hydrogen atom. So 1 gram will represent what? 1 mole of hydrogen atom. 1 gram, when I say, it is the gram atomic mass. So 1 gram represents 1 mole of hydrogen atom. And we know 1 mole of hydrogen atom contain Avogadro number of hydrogen atom. Or we can say 6.022 into 10 raised to 23 atoms of hydrogen will weigh 1 gram. Okay, so you got the difference between atomic mass and gram atomic mass. Atomic mass means mass of atom in U, whereas gram atomic mass is the atomic mass expressed in grams, and it is also equal to the mass of 1 mole of atom. Okay, now next term is gram molecular mass. Gram molecular mass, bracket Gmn. So when you see, it is molecular mass. So gram molecular mass means it is the molecular mass expressed in grams, or it is the mass of 1 mole of a molecule. So gram molecular mass is the mass of 1 mole of a molecule. Now as an example, (32U) represents 16U represents oxygen atom. So 32U will represent oxygen molecule. It represents O2 molecule. Now what about 32 gram? 32 gram represents 1 mass of 1 mole of oxygen molecule, or 32 gram represents 1 mole of O2 molecule. And we know 1 mole will contain Avogadro number of O2 molecule. Or we can say 6.022 into 10 raised to 23 oxygen molecule will weigh 32 gram. Okay, now instead of using the word gram molecular mass, we can also use molar mass. So what do you mean by molar mass? Molar mass is the mass of 1 mole of a substance in gram. So, instead of gram molecular mass, we can also use molar mass for 1 mole of a substance. So, molar mass is the mass of 1 mole of a substance in gram. Now, I will give you one more example. U represents, you know that 18 is the molecular mass of water. So, 18U represent 1 water molecule. Now, 18 gram represents 1 mole of water molecule. And we know 1 mole will contain Avogadro number of water molecule, or 6.022 into 10 raised to 23 water molecules. Okay. Now, 18 gram represents 1 mole, which means 6.022 into 10 raised to 23 water molecule will weigh 18 gram. That's the meaning of this. Okay. So, you can say the molar mass of water molecule is 18 gram, whereas its molecular mass is 18U. So, 18U we use only for molecular mass. So, they are same in magnitude, but the unit is different. And molar mass of water is 18 gram. Okay. Now, next you have a term called molar volume. Molar volume. Volume is for gases. So, molar volume is the volume occupied by 1 mole of any gaseous substance at STP. STP, that is standard temperature and pressure. And standard temperature and pressure is 273 Kelvin. Standard temperature is 273 Kelvin and pressure is 1 atm or 1 bar. So, this is molar volume. Molar volume is the volume occupied by 1 mole of any gaseous substance at standard temperature and pressure, that is 273 Kelvin, and 1 bar or 1 atm pressure. Now, again 1 mole of any gaseous substance will occupy 22.4 liters at STP. Okay, so 1 mole of gases occupy 22.4 liters at STP. So, this is something very important. 1 mole of any gas will occupy 22.4 liters at STP. So, this is molar volume. Now, the next term coming here is equations. Now, we have 2 important equations which is used in the calculations of moles, in mole concept. So, the equations, the 2 important equations. The first equation is to find the number of moles. Number of moles denoted by small n. Number of moles is equal to mass in gram divided by the molar mass or atomic mass. Atomic mass also in grams. Sorry, molar mass or atomic mass in U. Atomic mass is in U. Or we can say small n is equal to mass in gram denoted by W divided by molar mass or atomic mass denoted by capital M. So, this is the expression to find the number of moles. Small n represents the number of moles, capital W is the mass, given mass in gram, and capital M can be the molar mass or the atomic mass. Now, the next equation is to find the number of particles. So, equation number 2. Number of particles. When I say particles, It means atoms, molecules or ions. Number of particles is equal to number of moles, small n, into Avogadro number. So number of particles is equal to number of moles into Avogadro number. Or again, when you write it as an expression, we get number of particles is equal to number of moles is given mass by molar mass. So W by capital M into Na. So this is the expression to find the number of particles. And if number of particles is given, you can find its mass or molar mass, etc. Okay, so this is these are the two equations used in mole concept. Now the last term coming here is percentage composition. Percentage composition. Now, what do you mean by percentage composition, or this is also called mass percentage? Percentage composition or mass percentage. It is the mass percentage of an atom present in a compound, or there is an expression to find the percentage composition or mass percentage. It's given as mass percentage. It is the percentage of atom in a given compound. Mass percentage is equal to mass of elements in compound divided by molar mass of compound into 100. So this is the expression to find the mass percentage. Now there is one question written on the board. Question number 2. In 1 mole of carbon dioxide gas, find number of particles in CO2 gas. 1 mole. In 1 mole, what is the number of particles? It contains Avogadro number, that is 6.022 into 10 raised to 23 particles. Now, what is the volume occupied by 1 mole of carbon dioxide is STP? We already discussed. All gases will occupy 22.4 liters at STP, 1 mole of all gases. So here 1 mole of carbon dioxide will occupy 22.4 liters at STP. Molecular mass of carbon dioxide. We know carbon atomic mass is 12 plus oxygen, we have 2 atoms into 16 will be equal to 32 plus 12 will be 44 U. The unit is U, unified mass, because it is molecular mass. Now, molar mass of carbon dioxide will be the same, 44 itself, but the unit will be gram, because it is molar mass, that is the mass, molecular mass expressed in grams. Now, mass of 1 mole of carbon dioxide. Mass of 1 mole of carbon dioxide is again is known as molar mass, so it will be same, it is 44 grams. So with this we complete our mole concept. Thank you.